morning. We are the Group 10 of the TS project. Our topic is Air Quality Index. Our team members are me, Pritam Raj, Priyanshu Patra, Puspanjay, Rudrans, Sanskar Singh, and Sasiranjan Kumar. In this project, we have analyzed, interpreted, and visualized the air quality in different cities of India, how the concentration of all different gases varies over the time for different cities, which city has the highest concentration of which gas in which year, or which gas is highest in which city. We have also given hypothesis and tested it. Firstly, we have data collection, then data pre-processing and cleaning, then data visualization, after that data statistics, and after that hypothesis testing. So let's start with data collection. Data collection is the first process in any data analysis. Here we collect data, or we should say we collect data points to do the further analysis. Actually, data collection is the process of gathering and measuring information on variables of interest in an established systematic fashion that enables one to answer stated research questions, test hypotheses, and evaluate outcomes. We have taken our data from Kaggle. The link is given below. Now Puspanjay will explain data cleaning and pre-processing.
We have performed cleaning and pre-processing of our dataset using the Pandas and NumPy library of Python. At first, our data was in a single CSV file with three dimensions of information: pollutants along the columns and cities and dates along the rows. We have broken the single CSV file into multiple CSV files based on the pollutants containing two dimensions, cities along the column and dates along the rows. Now comes the filling step, where we fill the gaps of missing data in between two available data points, at max 5 missing points using an arithmetic progression series. After this, we have created a function that makes a new CSV file containing only those cities which have more than 80% available data. On running this code over the years range 2015 to 2020 for all the pollutant CSVs, we find cities that appear common in all the CSV files. That is, the data of all the pollutants is available for these 5 cities. Now in these 5 cities, we find that continuous data of pollutant level is available from 2017 to 2020. There might have been a few cities that could have more than 80% available data in the range of 2017 to 2020, but running the filter function in the interval 2015 to 2020, their cities were removed. So we run the code again to filter out cities that have more than 80% available data points in the interval 2017 to 2020. In this way, we finally obtain 7 cities which have data for all pollutants except xylene, over which we perform future analysis. Now I am handing over to Sasiranjan Kumar to explain the data visualization part.
After cleaning from the above dataset, we are going to visualize the concentration of different cities over time. We have used matplotlib library to generate the graph from the dataset, which you will see in upcoming slide. In our graph, we have fixed the pollutant. Like in this case, we have fixed NO2, here we have fixed toluene, SO2, PM2.5, PM10, and in similar manner we have fixed the pollutants and displayed concentration level of a particular pollutant like NO2. Concentration level of pollutant is polluted against time of different cities which is represented here. We can interpret from NO2 variation curve. NO2 is highly released in cities like Patna, Delhi, Gurugram, and at the same time Thiruvananthapuram low level of NO2 concentration were recorded. Similarly, here we can see in mid 2018 the pollution level of toluene in Patna increased rapidly, and in similar case in the Delhi. And in below graph, the curve shown in the grey color represent concentration level of SO2 of Patna city. We can see how much high level of SO2 concentration in Patna and also same case in the Delhi. This hazardous gas depict Patna and Delhi as one of the most polluted city of India. Now we can see from the graph in winter month here 10-2017 to 4-2018 the concentration level is high, and in summer months the concentration level is low, and can be seen in almost all the graph. Here you can see here too, and similar here, and this conclude to a region. Winter month pollution level increases and summer month it decreases. One of the possible reasons lies in fuel consumption level, which increases in winter to provide heat, and this pattern is seen in almost all the pollutants NO, NG. And finally, the graph of air quality index gives us a comparison of level of air pollution in different cities of India. Here we can see Delhi, Lucknow, Patna, Gurugram, high level of AQI level. This show these four cities are polluted very much. And in other case, Thiruvananthapuram, it is the least polluted among these cities. Now Sanskar will speak on data statistics part.
Data statistics. This table shows the cities having the highest and the lowest concentration of a specific pollutant for the years 2018, 2019 and 2020. For example, if we take the third row, then it shows that for the pollutant NO2, Delhi has the maximum average NO2 concentration in the years 2018, 2019 and 2020, while Thiruvananthapuram has the lowest average concentration of NO2 for the year 2018, 2019, and for the year 2020, Chennai has the lowest average concentration of NO2. Similarly, we can check for other pollutants too. We observe in these tables that Delhi appears frequently as the city with highest pollutant concentration for different pollutants over the 3 years. Similarly, Thiruvananthapuram appears most times as the city with lowest pollutant concentration. So, we can say among the 7 cities we have considered in our analysis, Delhi is the most polluted city and Thiruvananthapuram is the least polluted city. The next chart shows the air quality index levels based on the health concern and their corresponding numerical values. This table shows the average values of AQI of different cities over the year interval 2017 to 2020 and their corresponding level of health concern based on the previous chart. We can make an interesting observation from this table. Cities in south, Bangalore, Chennai, Hyderabad and Thiruvananthapuram have moderate AQI levels, while cities in north, Delhi, Lucknow, Patna and Gurugram have very unhealthy AQI levels. This might have a connection to the higher development index in South India and hence more awareness about the hazards of air pollution. Now handing over to Priyanshu, who will talk about hypothesis testing.
For hypothesis testing part, we shall do our analysis on Delhi, which is the capital city of India as well as one of the most polluted cities. We shall try to prove our hypothesis. The air quality of Delhi has decreased over the years. That is, we shall try to prove that the mean AQI level of 2019 is less than the distribution of mean AQI levels over the years 2015 to 2019 over a critical region of 5%. So, our null hypothesis is that the mean AQI of 2019 is equal to the mean of the distribution over 2015 to 19, while our alternate hypothesis is to prove that 2019 AQI mean is less than the distribution mean. We do not consider data of 2020 since there has been an abnormal decrease in pollution levels since the COVID-19 pandemic. The following are the calculations for our hypothesis testing. Mu denotes the mean of AQI distribution from 2015 to 19. Sigma denotes its standard deviation. X bar denotes the average AQI in 2019, while N denotes the number of data points. We shall perform a one-tailed z-test since we have 365 data points, which gives a high degree of freedom. Also, The AQI distribution of 2015 to 2019 is a near normal distribution as can be seen from the graphs in the right. Taking our critical value p is equal to 0.05, we obtain a critical region where z value less than -1.645 means that null hypothesis fails. The z value obtained from our data is -5.857, which lies in the critical region. This proves that the null hypothesis is false, and our hypothesis that the AQI of Delhi has decreased over the years is proven true. Now, Rudransh will conclude our presentation.
Hereby concluding our presentation, I would like to add that during the analysis of this data, we found the concentration of different air pollutants is highest in Delhi. Henceforth, the overall air pollution index is also highest here, whereas Thiruvananthapuram has had the lowest overall air pollution in this period between 2017 to 2020. Although, when analyzing annually, it was evident that the average air pollution in Delhi has decreased year by year. This proves that the citizens and government of India are becoming self-conscious and taking serious steps to improve the air quality of our country. In this slide, we have added the link of GitHub repository containing the source code of our project. These codes were used for data processing, data cleaning, and data visualization. The important Python libraries used in this project are OS, Pandas, NumPy, and Matplotlib. Here you can see our code that we have used in this project. So that's all from our presentation. Thank you and have a nice day.